Hey guys, welcome to day zero of my free networking course. I'm Tando, and you're about to embark on an exciting journey into the world of networking with network coders. Shout out to you for choosing to start this journey with me. I trust you'll find this course both enjoyable and informative. So, by the end of today's lesson, you'll have a solid understanding of what networking is, the different types of networks, various network topologies, and the essential network components. Don't forget to subscribe, comment down below, and hit the notification button. Hey guys, welcome once again. So in today's session, we're really going to be unpacking a lot about networking and starting off with what is networking, network components, and the network topologies. So when you think about networking, what comes to your mind? Do you think about the physical layout? Do you think about how the components are structured in the network? In your home right now, what kind of network setup do you have? Do you have routers? Do you have printers? Do you have PCs? So today we're really going to be unpacking a lot. And in essence, a network is actually the process of connecting computers and other devices to share resources and information. So you have the ability to share data and access shared resources like printers, files, and application. So in the real world, you'll be basically interacting with file sharing, video chatting, surfing the web, social media, streaming video, and email messaging. And the first network component that we'll be looking at today is the client. So a client is any device that accesses and uses the network services. So this includes computers, smartphones, tablets, and other connected devices. So, in essence, a client is anything that subscribes to the network. So it could be your printer, it could be your PC, it could be your smartphone. So, right now, what are you streaming from? Are you streaming from your laptop? Are you streaming from your cell phone? So, client subscribes to your network and actually utilizes the resources that are in the network. The second network component is the server. So a server is dedicated to centralizing resources. It provides resources to the rest of the network. Servers can implement and enforce security policies, manage user access, and ensure data integrity. And now we're going to be looking at the modem. So a modem connects your network to your internet service providers and translates digital data from your network into a signal that can be transmitted over a phone or cable lines. So it modulates and demodulates digital data to and from the ISP. So it converts it into a signal that your home devices can understand. And the key functions of a modem is connecting to your internet service provider and also converting signal. So the modem links your home network to the internet by connecting your ISP through a phone line, coaxial cable, or fiber optic line. And then by means of converting the signal, it actually translates the digital data from your ISP into a format that your devices can use, and vice versa. And the next network component that we're going to be looking at is the hub. So a hub is an older technology that we use to connect network devices such as clients and servers. So unlike a switch, it actually broadcasts data to all devices, which can lead to a lot of inefficiencies. So a lot of the times I call it a dumb switch, because when you actually send packets through the hub, it sends the packets not to the source, the specific source that you need to send the packets to, but it broadcasts all the packets to all the devices that are connected in the network. The next network component that we are looking at today is the switch. So a switch connects network devices such as clients and servers. So it's also like a hub, but it's a clever hub. And switches can learn what devices are on which ports, and switches only forward traffic received from a port to the destination port on the device's MAC address. So the nice thing about a switch is that it actually learns and figures out which device is connected to which port, so that it makes it easier for you to send packets from the source device to the destination device that you need to send data to. So the next network component that we're going to be talking about is the router. So a router connects two different networks together, and it intelligently forwards traffic to and from a network based on its logical address. And then most routers use Internet Protocol to determine routing of traffic. So it uses IP addresses to forward data. An example would be me trying to make a search on Google and accessing Google servers. So my network would obviously have to be translated into an IP address, and then the router would have to route that search request to Google servers and then back into my network with the data that I requested. The next component is the media. So, what connects us to different devices and other networks? So, it connects two devices or a device to a port. So, it's made from copper cable, fiber optic cable, or radio frequency waves. So, in the next sections of the course, we'll be talking about the media in depth with regards to the standards of the cable and the amount of bandwidth that's carried throughout the different cables. But in essence, the cables that are used in a LAN network, for example, you would obviously know that there's a RJ45 that you can use to connect to your PCs, and to switches to relay information and data. So that's pretty much one example that I can give to you, but there's many more. So we'll be looking at other examples in the next sessions of the networking course. And now we're looking at the wireless access point. So it's a very powerful device that allows wireless devices to connect into a wide network. So it's commonly used in homes, small businesses, and even in large enterprise networks. The next network component on our list is the WAN links. So WAN links are essential for connecting different networks over large distances, making it possible for businesses and organizations to communicate and share resources globally. So it could be lease lines, DSL, cable, fiber optic, and satellite, for example. And in this section, we are looking at the network topology. So when you're really looking at a network topology, there are two questions that you should ask yourself. Is it the physical topology, which means how the devices are physically connected by the media, or the logical topology, how the actual traffic flows within the network? And the first topology on our list is the bus topology. So it uses a running cable through the area required for the network connectivity. So each device taps into the cable using either a T connector or vampire tap. And it's actually an older technology which is not commonly used anymore. So devices on a cable form a single collision domain. And now we look at the next topology, which is the star topology. So devices connect to a single point. So it's commonly used with Ethernet cable, but wireless or fiber is also used. So if the central device fails, the entire network fails, which is not ideal for a big network. So if that central point, which is connecting all the components within that network, fails, the entire network fails and there is no connectivity throughout. And then similarly to the star topology, which is the hub and spoke. So it's similar to a star topology, but with WAN links instead of LAN connections. So it's also not redundant. If the central office, which is the hub, fails, the whole network can fail. And next we look at the full mesh topology. So it's basically the most redundant topology. Every node connects to every other node. Optimal routing is always available and very expensive to maintain and operate. So it's very redundant because When you connect different devices on this network, the nodes of the different devices connect to every other node within the network itself. So it's very redundant, and when one connection fails, you can still route your data using a different node, basically. So in this section, we'll also look at the partial mesh topology. So it's hybrid of the full mesh and the hub and spoke topologies. So it comprises of the two and provides optimal routes between some sites while avoiding the expense of connecting every site. And the last section that I've added for you guys is a packet tracer diagram, which comprises of a network. So it's basically a small network comprising of two pieces, a switch, an internal router, internet service provider router, and a Google web server. So in this network is basically the PCs wanting to communicate with a web server. But as I've mentioned in the previous slides, is that when you want to communicate with an external network, you obviously want to have a router in your network so that you can use the IP addresses to translate the data between the two different networks. So the PC would be interacting with the switch, and the switch would then translate the layer 2 MAC address into an IP address so that you can be able to connect it to the router, and then the router can route the packets from the PC side to the Google web server to make whatever request you want to make. So networking is actually a powerful tool that you are wanting to understand for future reference in terms of knowing how data flows in the network, because it's ideal so that you can be able to diagnose even when a packet has been lost within the network. You will be able to interact with different softwares to interact with the traffic in the network, which I'm going to mention in other sections of the course. So I want you to stay along, and as always, see you in the next one.